Good afternoon, good morning, good afternoon, good evening, good night, depending on when you're watching this. We are going to go over the calculations of the mean and variance of a binomial random variable. So we have established that a binomial random variable is a random variable that counts the number of successes across n Bernoulli trials. In a situation where we are working with n Bernoulli trials, for example, leading up to slide 25, we were looking at a situation where we were drawing 8 cards with replacement from a standard deck of cards. So that's 8 Bernoulli trials. We might be interested in computing the average number of expected successes, which is mu of x, which is the same thing as the expected value of x, and the standard deviation or variance associated with this value. In the situation we are working with a binomial random variable, the mean of x or the expected value of x, those are the same thing, and the variance can be computed using the formula in equation 5. So these computations are actually quite simplistic once we have identified the random variable as being binomial. All right, so we return to the illustration that we've been working with up until this point. So an experiment consists of drawing a single card from a deck 8 times with replacement. So we have little n is equal to 8, and we have little p is the probability we draw a club. The reason that it's the probability we draw a club is because, as you can see in the first question, part A, we are asked what is the expected number of clubs. Okay, so there's 13 clubs in a deck, 52 total cards. That's 1/4, which is 0.25. It doesn't matter if we use the fraction, if we reduce the fraction, or we use the decimal. Any of these values, 13/52, 1/4, or 0.25, will lead us to the same answer. Okay, the question asks us, what is the expected number of clubs? Okay, so the expected number of clubs, so E of x, and what we are assuming here is that let x count number of clubs. Okay, so the expected value of x is the same thing as the mean of x, which in the case of a binomial random variable, which is what x is n times p. So that's 8 times 0.25, which is 2. Okay. So if we were to draw 8 cards from a deck with replacement, so we draw a card, put it back in, shuffle it, draw another card, put it back in, shuffle the deck, we would expect to observe 2 clubs across those 8 draws. Okay, what is the standard deviation associated with this number? All right, well, we can see that the variance of x is n times p times 1 minus p. Okay, so this is going to be 8 times 0.25 times 0.75, which is 1.5, right? Okay, or sorry, we don't need this yet. And we want the standard deviation. So we have sigma x is equal to the square root of 1.5, where the square root of 1.5 is going to be 1.225. Okay. So in lecture set 4, we have seen 2 methods for computing expected value, and we have seen 2 methods for computing variance or standard deviation. If we are working with the general discrete random variable, we would use the formula given to us back at the start of the lecture set when we introduced the general discrete random variable. We can technically use that formula here as well, but that would require us to compute all the different probabilities of observing 8 clubs across 8 draws from a standard deck. Instead, because we know x is binomial, we can simply apply the formula given in 5 to compute the expected value and the associated standard deviation. If you have any questions, please let me know.